All right, our warm-up for today is just like one of the sections we did yesterday. We're evaluating the f function, this is f of x, at these values. So we want to start by plugging 0 in everywhere you see an x. So this is going to be f of 0 equals negative 2 over 0 minus 4. When you simplify the bottom, you get negative 4. Negative 2 over negative 4 simplifies to a half. Questions on that one? The next one's a little different. We're plugging in 2b. It's the same process. So everywhere you see an x, you would write a 2b. So we're finding f of 2b. It's negative 2 over 2b minus 4. Now, these are not like terms on the bottom, but there is something we can do to simplify this. Anybody know? Yeah, we can reduce. You can see that every term in the denominator has a factor of 2. So I could rewrite it like this. And then these 2's are going to cancel out. So you have negative 1 over b minus 2. Another way to do it, some people just go to this step. They cross everything out and reduce it by 2. So you'd have a negative 1 up here. This would be 1b. This would be minus 2. You should end up in the same spot that I ended up. Any questions on that? Today we're going to do the second section of chapter 2. It's all about slope and rate of change. Our objective or our goal for today is to examine slope. Like was brought up earlier, a lot of this I'm sure you've already seen. We'll go in a little bit more depth than you've done in the past, but this should all look very familiar. Here's a list of important things to know about slope. Slope, by definition, is the steepness of a line. We use the letter m to represent slope, as you can see in this formula right here. Slope is basically finding the change in your y values over the change in your x values. Another way you might see it written is with the Greek letter delta. So if you ever see this, it looks like a triangle, triangle y over triangle x. It's actually delta y over delta x. That means the change in y over the change in x. So as you get into upper level math classes, you'll see it written like this a lot more than you see it written like this, but it means the same thing. So the first three are just basically general information about slope. 4 and 5 get a little more specific. So parallel lines, those are lines that go on forever and never intersect. They have the exact same slope. So they have the same steepness. They look like this. They will never touch. They have the same slope. I'm sure you did a lot with those in geometry. Next is perpendicular lines. The quick right perpendicular is an upside down capital T. We use that symbol because it shows two right angles. Perpendicular lines form right angles. Look like this. Their slopes are opposite reciprocals. If you aren't sure what that means, you flip the fraction, change the sign. What are your questions on slope? Here's some more information you need to know about slope. A vertical line that's straight up and down, the slope's undefined. Horizontal line, side to side, has a slope of 0. Going from left to right, if your line is going up, the slope is positive. If the line is going down, the slope is negative. Now, I want to go back to point 6 and 7 for a little bit, because people mess these up. So I'll tell you why mathematically it works, and then I'll give you a little memory trick that I like to use. So for a vertical line, the slope is undefined. The reason that is, if you picked points along this line, they have the same x value. So mathematically, when you're finding the slope, if you're subtracting the x's on the bottom, you'd get a 0 on the bottom. Anytime you divide by 0, it's undefined. So mathematically, that's why that's undefined. Horizontal lines are similar. When you graph these, they would all have the same y value. If you subtract the same number on top, you get a 0 on top. 0 divided by anything is 0. So that's why one's undefined and one's 0. Just depends if your x's are the same or your y's are the same. Now, that idea kind of confuses people. So especially when I teach this to my freshmen, I like to remind them about skiers. So if you were a skier, I'll draw a little skier.
Skiing is hard.
Give them a little cap. Skiing is hard.
Well, I fell.
A little ball on the top. Okay, so that's my skier, right? He's obviously cross-country skiing, so we'll give him the little poles. All right, so if you're skiing, this is you. You are on a horizontal line. How fast would you be going? If you didn't push yourself, how fast are you going? 0. Okay? You are going 0 miles per hour. The slope is also 0. Okay, so think of yourself skiing if you're stuck. Now, we'll look at the other one. Again, you are skiing. You accidentally end up on a ski run that is completely vertical.
I want to see that.
What might end up happening to you? I don't really know. We'll just say you're undefined. I don't know. Okay, we don't know what's going to happen. You can't tell. All right? So if you get on some sort of ski lift that looks scary, straight up and down, we don't know. Your fate is undefined. But if it's horizontal, you're going to be fine. You're just going 0 miles an hour. All right, so if the skiers help, great. If not, think about what is the same value, the x's or the y's, and how would that affect your slope formula. I think the skiers is easier, but mathematically the other way makes a lot of sense too. Any questions on slope? Students are usually pretty good about points 8 and 9. If the line's going up, it's positive. If it's going down, it's negative. Pretty simple there. Any questions? So for this example, we're going to use those 2 points that they gave us. We're going to answer 4 questions about it. You have to go in order. You can't really do anything until you find A. So don't try to skip around on these. So before we start, let me remind you of the slope formula. We said slope is the change in y over the change in x. Now, I'm going to label these points. This is the first x value they gave me, so I'm going to call it x1. This is the first y value they gave me. I'm going to call it y1. Second x they gave me, second y they gave me. Any questions on where I got this formula or why I labeled these points the way I did? All right, I'm going to plug it in. So my y2 value here is 6. My y1 value is 0. My x2 value is 7. My x1 value is 3. Then I simplify. 6 minus 0 is 6. 7 minus 3 is 4. That simplifies to 3 over 2. So this is my slope. Now students always say, well, what if I wanted to say 0 minus 6, 3 minus 7? You would end up with the same thing. You would end up with a negative over a negative, which turns into a positive. That's fine. I always do the second one minus the first one. As long as you're doing y's on top, x's on the bottom, you should end up with the same answer. Okay, so this is our answer to part A. Any questions on how I got that? Part B says, find the slope of a line perpendicular to this line. Perpendicular lines have what kind of slope?
Parallel is B.
Oh, whoops. Parallel. Skipping ahead. Parallel lines have what kind of slope? The same. Now we're getting into perpendicular. What do I do to find the slope of a perpendicular line? The reciprocal.
And change the sign.
Wonderful. Flip it, change the sign. Now, part D is asking me about the original line I was talking about. So, the line through these 2 points. Is this rising, falling, horizontal, or vertical?
Rising.
Rising. How do you know it's rising?
Because it's positive.
Because it's positive. Good. If it's 0 or undefined, that's when you get into the vertical horizontal. For rising, it's a positive number. For falling, it's a negative number. What are your questions on slope? We're going to start number 2 the same way. I'm going to remind us all of our formula. Subtract the y's, subtract the x's. I'm going to label my points. x1, y1, x2, y2. y2 in this case is 6. y1 is 0. x2 is negative 4. x1 is also negative 4. So minus negative 4 on the bottom. On the top, I'm going to get a 6. What do I get on the bottom? 0. You cannot leave your answer like this. Okay? This is something that's mathematically not correct. What do we say?
6.
No.
Isn't it like
Undefined. Good. This is an undefined slope. So a line parallel would also have what kind of slope? Undefined. Good. So we kind of talked about how undefined slope means we have a line vertical, right? So a line perpendicular to that would be horizontal. What's the slope of a horizontal line? 0. So this one you can't really just remember, flip it, and change the sign. You have to think about it a little more. You could actually look back to this step right here. If you flip this, you'd have 0 over 6, which would be 0. You don't have to worry about the sign. Okay? And then I already kind of answered D for you. Remember what I said? Vertical line. Good. So this is one that I would consider a special case. Anytime you have to think about horizontal or vertical, it kind of trips you up a little. So be aware of that. Any questions? Like previous examples, I'm just going to start by labeling my points. I want to subtract which one, x or y on top? Y. 5 minus 5. And the x is on the bottom, negative 2 minus 7. I'm getting 0 over negative 9. So what's my slope here? 0. Great. For these next couple, it might help you to visualize this line. If it has a slope of 0, it looks like that. So a line perpendicular to it would have what kind of slope? Did I say perpendicular again?
Yeah.
I just want to do perpendicular first, I guess. Let's do C first. What would that one be? Undefined. Good. If you have 0 over something and you flip it, it would now be undefined. Or you could think back to what type of line would be perpendicular to a horizontal line. It'd be a vertical line, so it has to have an undefined slope. Back to B, parallel this time. 0. Good. I think I skipped those because they're just so easy. And then D, our original line, I drew it in blue. It's horizontal. Good. So if you get confused on the special cases, look back in your notes. You should have had them all written down. Questions? Now we're going to find slope using a graph. Does anyone remember how you do this? Rise over run. Good. It's still the change in y, but another way we say change in y is the rise. Another way we say change in x is the run. So I'll just remind you that's delta y, delta x, or change in y over change in x. So start at one of the points they gave you. And then count the rise. How many do you go up to get to the next point? 3.
Oh, yeah.
How many do you run? 1. What's 3 over 1? 3. So the slope here is 3. What are your questions? Now, some people don't like this method, the rise over the run thing. That's fine. You could actually go through and label these points. So this is for 1. This is 5, 4. And you could use the slope formula on those 2 points. You should still come up with 3 as your answer. So it's really up to you how you want to do this. Most people just count the rise over run, but I have seen students label the points and actually use the formula because they like that method more. Or you could do both. Double check. What are your questions on this? Here's another one. The points are already labeled here, so this is definitely one where you could do the y2 minus y1 over x2 minus x1. Or you could just count the rise over run. So rise implies you're going up, but it's really your change up or down. So this one they're going down 1, 2, 3. Anytime you go down, what type of number do you think that'll be? A negative. And then we're going over 1, 2, 3, 4. And that's to the right, so it's a positive. So my slope here is negative 3 over 4. Which makes sense because from left to right, this line is going down. So you can always double check your signs on these. If the line's going up, you should end up with a positive slope. If it's going down, you should end up with a negative slope. What are your questions? All right, here's the last type of example we're going to look at today. We are just, well, actually, there's one more type, sorry, to ruin the surprise. This is the second last type. We are trying to decide if these lines are parallel, perpendicular, or neither. So you have to find the slope of both lines. The slope of the line that goes through this set of points, the slope of the line that goes through this set of points, and then decide if they're the same, they'd be parallel. If they're opposite reciprocals, they'd be perpendicular, or if they're not related at all, you'd say neither. So we should be getting pretty good at doing slope. So I will just subtract my y's, subtract my x's. Be careful with your signs. On the bottom, you have 3 minus negative 3. So on the top, I get 3. On the bottom, I get 6. The first one has a slope of a half. Questions? Now I'm going to find the slope of the second one. So I have 1 minus negative 3 and 4 minus negative 4. That gives me 4 over 8, which reduces to a half again. So these have exactly the same slope. So what type of lines are they? Parallel. Great. And you don't have to write it out. You can use the symbol. I'm fine with that. Any questions? Same thing over here. We're going to find the slope. Do your change in y over your change in x. I'm coming up with 2. Change in y on the bottom one. Change in x. I'm getting a half. The first one was 2. The second one was a half. I heard 2 answers. Perpendicular and neither. To be perpendicular, what do they have to be? Opposite reciprocals. They're reciprocals. Are they opposite? No, they're both positive. So this is neither. What are your questions? Now, I did say there was one other thing. This one's actually pretty simple. We're talking about steepness. So to find steepness, it's which one has the greatest absolute value. So you forget about signs once you find it. Whichever one has the highest numerical value, forget about the signs, we're doing absolute value, is the steeper line. So you start these the same way as you start example 6. We just need to find the slope of the line through each of these points. Then we're going to compare the steepness. So again, I'm going to do change in y over change in x. I'm getting a half on the first one. And 5/8 on the other one. Now, these are both positive, so just compare them. What's bigger, a half or 5/8? 5/8. So that is the steeper line. So line 2 is steeper. What are your questions on this? Steepness of a line. If you graphed these, line 1 would look something like that. These are definitely not exact. Line 2 would look something like that. So line 2 has a faster rate of change. It's changing. The y's are changing quicker than the change in the x. So that's what we mean by steepness. And again, it's just absolute value. Don't worry about the signs. But in this case, they're both positive. Let's look at the next one. Again, I want to do change in y over change in x. Oh, that one went off the screen, sorry. I'm getting -1/3 on the first one. And 13 over -40. So they're both negative. That doesn't really matter. We need to figure out what's greater, 1/3 or 13 over 40. Anyone have a calculator? Do 13 divided by 40.
0.325.
So this one as a decimal is 0.325. 1/3 as a decimal is 0.333 repeating. So which one has a greater value? Yeah, -1/3. Good. So I'll just box in line 1. That's the steeper line. Again, don't worry about the signs. It's the absolute value we're talking about for steepness. What are your questions on slope? None? Alright, here's your homework. It's also on your green sheet. Again, odds, so you can check your work. I'll take questions on that tomorrow.